T-Rex stomping through Times Square, or a Brachiosaurus munching on trees in a city park. While it's fun to imagine, could these magnificent creatures actually survive in our modern world? Let's dive into the science and find out. The biggest, most immediate problem dinosaurs would face is something we all take for granted: the air we breathe. Today, our atmosphere is about 21% oxygen. But back in the Mesozoic era, when dinosaurs reigned supreme, the oxygen levels were much, much higher. During the Jurassic and Cretaceous periods, it's estimated that oxygen concentrations were as high as 30 to 35%. That's a massive difference. So why does this matter? Well, think about how our bodies work. We breathe in oxygen, which our lungs absorb, and our blood carries to every cell. This oxygen is crucial for metabolism, the process that converts food into energy. For the colossal dinosaurs, especially the giant sauropods like Argentinosaurus or Patagodeton, this high-octane, oxygen-rich air was like a supercharger for their bodies. Their respiratory systems were incredibly efficient, likely more so than ours. Many scientists believe they had a bird-like respiratory system with air sacs. This system allowed for a one-way flow of air through their lungs, meaning they could extract more oxygen with each breath compared to mammals like us, who have a two-way in and out system. But even with this super efficient setup, it was designed to work in a high oxygen environment. Imagine taking one of those giant sauropods and dropping it into our 21% oxygen world. It would be like an elite athlete trying to run a marathon at the top of Mount Everest without any acclimatization. They would be gasping for air, struggling to get enough oxygen to power their massive bodies. Their muscles wouldn't get the energy they need. They'd feel weak, lethargic, and constantly out of breath. For the largest dinosaurs, just the simple act of standing and supporting their own immense weight would become an exhausting, perhaps impossible task. They would likely suffer from chronic respiratory distress and eventually organ failure. It would be a slow, cruel end. But what about the smaller dinosaurs? A Compsognathus, about the size of a chicken, or a Velociraptor might fare a bit better. Their smaller bodies have a lower oxygen demand. They might be able to survive, but they'd probably be at a disadvantage. They wouldn't be the super agile, energetic predators we see in movies. They'd likely be slower, less active, and more vulnerable. Think about how you feel when you're at a high altitude. You get tired more easily. That would be their permanent reality. And it's not just about breathing. Higher oxygen levels during the Mesozoic likely fueled gigantism itself. More oxygen means more energy from food, which allows for bigger bodies and faster growth rates. The very reason dinosaurs could get so enormous might be tied directly to the air they breathed. In our world, the environmental cap on size would be much, much lower. So, even if they could somehow adapt to the lower oxygen, new generations of dinosaurs would likely evolve to be much smaller. The age of the giants would be over, replaced by an era of more modestly sized creatures. Now let's move beyond the air and talk about another critical factor: plants. The world's flora has changed dramatically in the last 66 million years. Back then, the dominant plants were things like ferns, cycads, and conifers. These were the primary food sources for the vast herds of herbivorous dinosaurs. Today, the plant kingdom is ruled by angiosperms, or flowering plants. Grasses, leafy trees like oaks and maples, and all the fruits and vegetables we eat are angiosperms. These plants didn't really take over until after the dinosaurs went extinct. So, a Triceratops or a Stegosaurus transported to our time would be like a picky eater at a foreign buffet. They would be surrounded by food, but it's not the food their digestive systems evolved over millions of years to process. Many modern plants have different chemical compositions and defensive compounds than the plants they were used to. They might not be able to digest them properly, or worse, many of our common plants could be toxic to them. Finding enough of their familiar ancestral food would be nearly impossible. They'd be forced to experiment, and that could lead to malnutrition, poisoning, and starvation. An animal that needs to eat hundreds of pounds of specific ferns each day would be in serious trouble in a world dominated by grass and flowering trees. Even the carnivores would have problems. Sure, a T-Rex could probably eat a cow. Meat is meat, right? But the ecosystem has changed. The prey animals today are different. They're faster, more agile, and often smarter than the lumbering herbivores the T-Rex was adapted to hunt. Mammals like deer or bison are not the same as a slow-moving Edmontosaurus. The hunting strategies that worked for a T-Rex in the Cretaceous might not be as effective against the quicker, more nimble mammals of the Cenozoic era. And then there's the climate. The Mesozoic was, on average, much warmer and more humid than our world today, with higher sea levels and no polar ice caps. Dinosaurs were adapted to this greenhouse world. While our planet is currently warming, we still have ice caps, and our climate is more varied and in some places much colder than what most dinosaurs were used to. A dinosaur from a tropical Cretaceous jungle would not survive a winter in Canada or Siberia. Even in warmer regions, the seasonal temperature swings could be too extreme for them. Being cold-blooded, or more accurately, something in between called mesothermic, their body temperature was regulated by their environment. Drastic cold could make them sluggish, unable to move, hunt, or escape danger. They would be incredibly vulnerable. Finally, let's talk about disease. Every animal on Earth lives with a host of bacteria, viruses, and parasites. Over millions of years, animals and their local microbes co-evolve, developing a kind of truce. Your immune system knows how to fight off the common germs in your environment, but a dinosaur's immune system would be completely naive to the trillions of modern microbes. It would have no defense against the bacteria in our soil, the viruses carried by modern birds, or the parasites in our water. They would be hit by a microscopic onslaught from all sides. A simple bacterial infection that a modern animal could easily fight off could be lethal to a dinosaur. They would likely succumb to diseases we consider trivial before they even had a chance to starve or suffocate. So, when you put it all together, the picture is pretty grim. The low oxygen, the unfamiliar plants, the different prey, the colder climate, and the modern diseases all create an environment that is deeply hostile to dinosaurs. They are creatures of a lost world, perfectly adapted for a planet that no longer exists. Could a few of the smaller, more adaptable species find a niche and survive for a little while? Maybe, but the magnificent giants like T-Rex and Brachiosaurus, their time has truly passed. They belong to the history of our planet, a spectacular chapter that is now closed. Our world has moved on, and it simply isn't their world anymore. It's a sobering thought, but it also makes you appreciate just how complex and interconnected life on Earth really is. Thanks for watching and thinking about this incredible what if with me. If you enjoyed this journey back in time, be sure to like this video, subscribe to the channel, hit that notification bell, don't miss our next exploration. Remy signing off, stay safe and stay curious. See you next time.